The most common numbers used in math are real numbers. 0, 1, 0.3, pi, and square root of 2 are all examples of real numbers. A complex number is a number that has two parts, a real number part, represented here by A, and an imaginary number part, represented by B. The pure imaginary part of a complex number, B, is multiplied by the imaginary number, I, which is why B cannot combine with the real number part, A. The parts are distinct. The imaginary number is represented by the letter I and is equal to the square root of -1. This, in turn, means that I squared is -1. Although the two parts of a complex number do not operate with each other, the real parts and the imaginary parts of two complex numbers can. In this example, the real parts of these numbers can add and subtract with the real parts, and the imaginary parts can add and subtract with the imaginary parts. The real parts of these complex numbers, 3 and 3, sum to 6. The imaginary parts, 4i and -2i, subtract to 2i, just like normal subtraction. The answer to this is the complex number 6 plus 2i. In this subtraction problem, 2 minus 3i minus the complex number 5 minus 10i, the first step is to remove the parentheses by distributing a -1 in the subtrahend. This will result in 2 minus 3i minus 5 plus 10i. Subtracting real terms from real terms and imaginary from imaginary terms, the final solution is -3 plus 7i. Multiplying complex numbers is no different from multiplying any other binomial. You can use the FOIL method, or you can distribute one complex number into the other. In the following example, 1 minus 2i times 3 plus 4i, the first factor can be distributed into the second. This simplifies to 3 minus 2i minus 8i squared. Before proceeding, it is important to notice I squared. I squared equals -1, which means -8i squared is equivalent to -8 times -1, which equals +8. If you proceed, you can now simplify this problem to 11 minus 2i. Complex numbers can also be graphed on a complex plane using points and vectors. A complex plane is similar to a coordinate plane, except that the y-axis is measured in imaginary units, whereas the x-axis is measured in the usual real number units. To graph the complex number, -3 plus 4i, a point would be graphed that is 3 units in the negative direction along the horizontal, real, axis, and 4 units in the positive direction along the vertical, imaginary axis. A vector is then drawn from the origin to the point to represent the complex quantity. Complex numbers can be graphically added and subtracted on the complex plane using points and vectors. For an addition problem, the first step would be graphing one of the addends as a point and then drawing a vector from the origin to the point. Next, instead of graphing the second point relative to the origin, it should be graphed relative to the first point. A vector is then drawn from the first point to the second point. This new point is the graphic solution to the problem, and a vector can be drawn from the origin to the new point to represent the sum. For addition, it does not matter which point is graphed first. It is best to graph both points, add the other complex number to each, and draw appropriate vectors. If done properly, the vectors should create a parallelogram that is split in half with the sum vector. Subtraction is similar to addition, except the second point will be shifted in the opposite direction of what the subtrahend suggests. Looking at the problem 2 plus 2i minus 2 plus 2i, the answer is going to be 0. On this plane, the minuend is plotted. Subtracting the subtrahend is accomplished by moving in the opposite direction that the original subtrahend indicates. Instead of shifting 2 units right on the real axis, as would be done in addition, the point will be 2 units left. Instead of moving 2 units up on the imaginary axis, it will move 2 units down. Subtraction can also be considered adding the opposite. If the negative is distributed in the subtrahend, the problem becomes 2 plus 2i plus -2 minus 2i, which can make this more explicit. Complex numbers also have conjugates, designated by a bar over the complex number, that can be used for more complex problems. The conjugate of a plus bi is a minus bi. If a complex number is added to its conjugate, the solution is twice the real part, 2a. If a complex number is multiplied by its conjugate, the answer is the magnitude of the original complex number squared. The conjugate properties become helpful when dealing with many operations, including more difficult multiplication and division. Complex numbers are numbers that incorporate real and imaginary parts. They can be solved algebraically or graphically, and are a fascinating extension of the number system.